Okay, so we look at simplifying expressions with multiple exponent laws, and I'll just mention that when you see the word simplify dealing with exponents, um, no negative exponents should be in your final answer. You can always make negative exponents positive exponents. So anytime you see simplify, you need to know that it means no negative exponents in your final answer. So example 1, let's look at 2 times x to the third y to the negative fourth, all raised to the negative second power. So the first thing I notice is that I've got an exponent on the outside for this product. So this exponent will go in and multiply by all of the existing exponents, and 2 is to the first. So you have 2 to the negative 2, x to the negative 6, and y to the positive 8 when you multiply all the exponents. And the easiest way to deal with negative exponents is if your expression is not a fraction, make it into a fraction by putting it over 1, and then remembering that negative exponents mean reciprocal. So anything with a negative exponent is going to become its reciprocal. In a fraction, what that means is it's going to move to the other side of the fraction. So the 2 to the negative 2 moves to the bottom and becomes 2 to the positive 2. So when you jump over the fraction bar, your exponent changes signs. So if a negative on top, it's a positive on bottom. Same thing with x to the negative 6 becomes x to the positive 6th on bottom, and your y to the 8th stays on top. So you end up with y to the 8th over 2 squared is 4 times x to the 6th, and that is it. In the second example, you do a similar thing, but what I notice first is that inside the parentheses I've got x to a power times x to a power, so I know I can add the exponents if I want to. So if I do that, I end up with negative 2 times x to the 0 power, because negative 4 plus 4 is 0. And then that's to the negative 4th. At this point you could distribute the exponent again, but in fact x to the 0 is 1, so I'm going to replace x to the 0 with 1. And when I multiply negative 2 times 1, I just have negative 2. So this simply becomes negative 2 to the negative 4th. Again, it's not a fraction, so I'll make it into a pretend fraction. And now this negative 2 to the negative 4th goes to the bottom and becomes negative 2 to the positive 4th because the exponent changes its sign. And on top, when you're moving things from top to bottom on a fraction, you leave behind ones. Or when you cancel top and bottom, you leave behind ones. Finally, negative 2 to the 4th power is positive 16. So here I'm going to work on the inside first, getting rid of all of those negative exponents, and I just want to point out that negative 3 is to the positive first exponent. So its exponent's not negative, so you can't move it. However, anything I'll highlight here with a negative exponent will be moving. So we have negative 3. If you want to write to the first, you can do that. The x to the 4th stays, x squared goes to the top, and y cubed goes to the top. And now the exponents there are positive. The y to the negative 7th moves to the bottom and becomes y to the positive 7th. And finally, all of that is to the negative 3 power. Now I will distribute my negative 3 in to all of these exponents. This is just one way to do this. You could have distributed your negative 3 at the beginning. So you end up with negative 3 to the negative 3rd power, x to the negative 12th power, x to the negative 6th power, y to the negative 9th power, all over y to the negative 21st power when we multiply all those exponents. Now everything here has a negative exponent, so we have to switch everything from top to bottom. So the y to the 21st is on top, negative 3 becomes to the positive 3 on bottom, x to the positive 12th, x to the positive 6th, y to the positive 9th. And now we reduce. For example, my y to the 21st and y to the 9th. These 9 y's cancel with 9 of the y's on top, leaving behind 12 of them. So I've got y to the 12th on top. Negative 3 cubed is negative 27, so I'll put my 27 here and put my negative in front of the entire fraction. X to the 12th times x to the 6th, we add those exponents because I have 18 x's on bottom. And there we go. There are no negative exponents, so this is completely simplified.